Recall that today we learned about our rules of exponents. Remember, exponents are our little numbers. So if I have x to the 7th, my exponent is 7. And this right here is my base. The x is my base. So our exponent rules, if you can remember the acronym NAME, it will help you out. We'll get to the E next class period. But if we're multiplying or dividing, that means we add or subtract our exponents. If we're adding or subtracting, we do nothing to our exponents. And my bases do not change. When I'm working on this stuff, the bases do not change. And remember that these rules apply to our exponents. They don't apply to our coefficients or anything like that. We still treat our coefficients as if they're regular numbers. So I have this problem, x squared y cubed times x to the 5th y. So I am multiplying, and my rule says when I multiply, I need to add my exponent. So this is the same as x to the 2 plus 5 times y to the 3 plus, don't forget if you don't have an exponent, there's a 1 there. So 3 plus 1. And 2 plus 5 is 7, and 3 plus 1 is 4. So this is really x to the 7th times y to the 4th. So I have the problem 12x to the 4th y to the 7th divided by 4x to the 6th y to the 3rd. Remember, when we divide, we have to subtract our exponents. And we always start with where there's more of. So with my numbers, I'm going to leave them there. 12 on top, 4 on bottom. I'll get to those in a second. My x's, there's more x's on bottom, so that's where I want to leave my x's. And then I'm going to do 6 minus 4. With my y's, there were more y's on top, so I'm going to leave that one there and do 7 minus 3. Well, the y's, I end up with y. 7 minus 3 is 4. X is 6 minus 4 is 2. With my numbers here, I still go ahead and divide those. We do not subtract our numbers. And 12 divided by 4 is going to be 3, and that is going to go on top. Remember, it's important to remember that your bases do not change. So even though this problem has these 4's here, these 4's are bases. On the previous problem, our numbers were coefficients. So there's going to be a 4 in our problem. There's more 4's to begin with. So I'm going to do 4 to the 10 minus 3. And I don't have anything on top, so I'm going to put a 1 there as a placeholder. And I end up with 1 over 4 to the 7th. And that would be my final answer. Remember, anything with an exponent of 0 is always equal to 1. It doesn't matter if it's a positive number or a negative number, it's always equal to 1. So I've given you 2 more problems, and I want you to notice that on one of them, the problem is, these 2 problems are identical, but one of them the negative is outside, one of them the negative is inside. So in this first problem here, this exponent of 0 applies to everything inside the parentheses. That's where it gives us 1. So on the second problem, this exponent of 0 applies to everything inside the parentheses, so it's going to also give us 1. However, this negative sign here, because it's outside, it still has to be there. This exponent right here does not apply to this negative sign because it's outside the parentheses. So the answer to this question is -1. Recall negative exponents. What we said is that they're unhappy. And so in order to make them happy, to make them positive, we need to move them. So if they're in the numerator, we need to move them to the denominator. If they're in the denominator, we need to move them to the numerator. So I have x to the x to the negative 7th equals 2. So currently, this is unhappy, so I need to put it in the bottom so it will be happy again. I'm going to leave everything else where it was. There's nothing on top, so I'm going to put a 1 there. So that would be my final answer. I have 6x cubed y to the 4th. So what's currently unhappy is this x cubed. So I need to rewrite this as a fraction. The 6 is happy where it is. Its exponent is positive. Y to the 4th is happy where it is. Its exponent is positive. But x to the 3rd was not happy because it was negative. So I need to move it to the denominator. So here's our last problem. We have 5 to the negative 1st, a to the 2nd, b to the negative 3rd on top, and 10, a to the negative 7th, b to the 4th on bottom. So I have some things that are unhappy, so let's just start with one at a time. The 5 to the negative 1st, because it's negative, it's unhappy, so I want to move it to the bottom. The a to the 2nd, it's happy because it's positive, so I want to leave it on top. The b to the negative 3rd, it's unhappy, so I want to move that one to the bottom, so it's going to be b to the positive 3rd. And then starting with my denominator, I have this 10. This 10 has an exponent of positive 1, so it's going to stay on the bottom and put a time sign there. This a to the negative 7th is unhappy, so I need to move it to the top. So it's going to be a to the positive 7th. And then my b to the fourth, it's happy because it's positive, so I want to leave it in the bottom. Now I can simplify this. Since both my a's are on the top, that means they're being multiplied. When I multiply, that means I add my exponent, so it would be 2 plus 7, which is going to be a to the 9th on top. In the denominator, I have my b's, b to the 3rd and b to the 4th. Since they're both in the denominator, they're being multiplied, so I can add my exponents. So 3 plus 4 is going to give me b to the 7th. With my coefficients, my 5 to the 1st and my 10, because they're not exponents, I need to go ahead and multiply those. And 5 times 10 is going to give me 50. So this would be my final answer.